right, welcome everybody. So just a little check here. This is my first time using GoToWebinar, so I just want to make sure the audio and the video is okay. I see myself on the video, and I'm going to assume the audio is all right. So unless I hear otherwise, we're good to go. All right, I've been told by my organizer, Brittany, here that we're good to go. So let's go ahead and move forward. So welcome to this presentation from INE, from yours truly, Keith Bogard, on SPAN and RSPAN. So we're just going to do a brief presentation here about these two particular features. And I've got a few slides to go through, but I'm also going to be doing some whiteboarding. And of course, I got some demonstrations to do on some actual lab equipment as well. And then once I'm done with that, hopefully you guys will be pretty close to being experts on SPAN and RSPAN, and then you can ask me whatever questions you want at the end. So feel free to go ahead and submit your questions as I go along. I mean, as it shows up in your head, you might as well write it down there before you forget. But I'm gonna wait until I get through all my material, and then once I'm done, then I'll go ahead and take a look at your questions and hit those up. So let's go ahead and start talking about SPAN and RSPAN. And I'm gonna take this from the standpoint that most of you don't know what these features are, and you're kind of curious what these features are. So we're going to take it from that level and work our way up. So if you want to, you might want to take a screenshot of this using Snagit or some image capture or something, because this is the topology I've got set up. You can't really see it, but right here in the corner, I've got 4 routers and 2 switches. My actual MacBook is going to be the laptop used to actually do the Wireshark sniffer captures and everything like that. So as I go through my demonstrations, if you have this picture in front of you, it will help you sort of keep track in your mind of, okay, what port did he just do, and why did he enable that as a SPAN source? So go ahead and take a screen capture of this, and then we can move on. All right, so you guys probably don't need to be told about this, that, you know, if you're a network administrator or some security administrator or whatever, there's going to be a lot of situations where you want to monitor your network. It could be that you sort of have heard through the grapevine that there's something fishy going on in your network. You know, maybe you've got some acceptable use policy that says, hey, on our corporate network, no internet gaming is allowed. And yet you've heard, over here in payroll, I've heard that, you know, from 8 o'clock on at night, there's some people doing, you know, whatever, some online racing or whatever they're doing, and I want to track down who exactly that is. So I want to let them go ahead and play their game, but I want to look at their packets to be able to hunt down the source IP address, the source MAC address of who's doing it. So that way I can, you know, make them work at McDonald's the next day or whatever it is I want to do. Or, you know, more realistically, you've probably got some sort of security appliance like an intrusion prevention system or intrusion detection system, and you want to send a whole bunch of network traffic to that device, because that device is constantly scanning your traffic to see, okay, does anything look like there's a malicious attack going on? Is there a denial of a service attack going on? Is there something that looks funny that this device should react to? So what we're talking about here is, at a high level, we want our traffic to be switched as normal. As traffic goes in and out of the switch, we want the switch to do exactly what it normally does, but we want to selectively copy some of that traffic and send copies of that traffic to a network monitoring device. Now, there's actually, at a real high level here, there's 2 sort of methods to do this. One is something called using a network tap. So a network tap is actually a physical device. It's a little box. And if you know in advance, if you say, hey, traffic is coming in, you know, maybe between 2 switches right here, or let's actually draw on this, for example. Let's say that you know that right here on this port, you just say, this is what I want to monitor, okay? Well, what you could do is, if you know in advance, you could put this network tap device right there between the router and the switch, connect it up, and then a network tap is kind of like a hub, in that you would then have your network monitoring device connected to that tap, and it would see copies of everything. Now, it's a little bit more advanced than a hub because it provides you timestamps as well as all sorts of other advanced features. So that's one way of doing it. So that's if you know in advance and you're able to, you know, get into work at 4 o'clock in the morning before people come in and plug that device in there without being intrusive to everybody. But let's say that's not the case. Let's say it's, you know, 3 o'clock in the afternoon and you've decided, hey, there's a particular part of my network that I want to monitor. And a second, let me get my thing over here. Okay, and I don't have the time to go in at 4 a.m. and install this device. I want to start monitoring it now, and I want it not to be intrusive to anybody. That's where you would use something like SPAN and RSPAN to do this. So SPAN stands for Switch Port Analyzer, and we'll talk about what RSPAN is here in just a second. But basically what this is a feature you can turn on a switch, and you can define what you want to monitor. And we'll look at that in just a minute. It could be a physical interface, a range of interfaces. You have several options as far as what you want to monitor. And whatever you're monitoring, frames that come in there, all frames, everything that comes in there is copied and then sent to a destination. And the destination is where your network monitoring device would be. So what we're focusing on here are the first two primary forms of SPAN, which is SPAN and RSPAN. So SPAN is also sometimes called local SPAN, because what this means is that the ports that you're monitoring on the switch and the destination port where your network monitoring device is connected to are all on one switch. They're all on one local chassis. So if you happen as a network administrator to be fortunate enough to be right there on the switch where you think the traffic is coming in that you want to monitor, you can do SPAN. And equally, if not more popular form of this is something called remote SPAN. So remote SPAN is where you say, hey, you know, there's switch 1 over there in building number 1, and I've got a port or a range of ports on that switch that I want to monitor, but I'm not over there in building 1. And quite frankly, I got stuff going on today. I don't want to move my laptop over to building 1 and connect to that switch and sit in that, you know, wiring closet all day capturing traffic. I'm over here in building number 5. The switch connected to me is switch number 5. So how do I capture the traffic on switch number 1, let it be switched as normal, but take those captured or copied frames and get them over here to me in building number 5 so I can see them popping out of my switch? And this is what RSPAN is all about. Now, in order for RSPAN to work, and I'm going to show you demonstrations of all this stuff, all the switches from the source switch where you're copying the traffic all the way to the switch where you're connected to as a network admin with your network monitoring device have to be connected at layer 2, and they have to be trunked all the way through. So think of, like, you know, an analogy to that would be like VTP, right? You guys probably all know about the VLAN trunking protocol. In order to have VTP work, all the switches have to be connected at layer 2. They all have to be connected via trunks. Same thing is true of RSPAN. Now, there is a third form of SPAN that we're not going to get into today, which is called ERSPAN. I'll just give you a real high-level overview of that, and then you can go off on your own and research that. Please don't ask me any questions about ERSPAN because that's not the focus of our stream today. But what ERSPAN is, it's kind of cool in concept, is that once again, I've got switch number 1. That's where I want to capture my traffic. That's over in building number 1. Now me, as a network administrator, I'm like on the other side of the country. I'm connected to switch number 20, and there is no layer 2 path between us. As a matter of fact, the only way I can even get over there to the other campus is via IP, via routing packets through the internet or over a WAN or something like that. So now the question becomes, how do I get my layer 2 frames I've captured over there on switch 1 through a routed cloud like the internet to show up on my switch where I can see them with Wireshark? That's what's called enhanced remote SPAN. And the general idea behind this is that between the two switches, you actually create a tunnel, a layer 3 GRE tunnel, generic routing encapsulation. And now as the packets come in, or I should say the frames come in on switch number 1, they get switched as normal, but then they get placed inside of a GRE header, which is inside of an IP header, and now it can be routed to your switch where it's decapsulated and then sent to you. So that's ERSPAN. Now, not all switches support ERSPAN. Pretty much all switches, at least Cisco switches, do support SPAN and RSPAN, but ERSPAN is not support on everything. So unfortunately, I couldn't even do a demonstration on that if I wanted to, because the switches I have physically in front of me don't do that. So we're going to focus on what I can show you guys, which is SPAN and RSPAN. Okay, so both in SPAN and RSPAN, in both of them, the first thing you have to ask yourself is, where's this traffic coming in that I want to monitor? In other words, what is the what's the switch that's receiving this traffic that I want to capture? And you've got several choices here. For example, let's say that this right here is your PC. I should say the PC of this person who's suspect, and this is switch number 1. Well, I could certainly select that port right there and configure that as my SPAN source. And so everything on that port I would copy and send somewhere else. Or maybe what I have is I've got a bunch of switches, you know, switch 1, switch 2, and please forgive my horrible handwriting right here, my drawing capabilities. And then I've got over here switch number 4, which is sort of like an aggregation switch. And I actually want this port to be my SPAN source. It's completely up to you. And as you can see here on this slide, your SPAN source could be a physical interface, a range of physical interfaces. I'll talk about direction in just one moment. You could have an entire VLAN. You could say, hey, all traffic coming in on VLAN 2, that's what I want to capture. On certain switches, depending on the hardware of the switch, you can even capture traffic going to and from the switch's CPU. That's typically done on the higher end switches, like your Nexus switches, your Catalyst 6800s, those types of switches support that type of thing. Typically think of a switch that has a modular supervisor. If you got a switch that has a modular supervisor, that gives you that capability. But your lower end switches, like your 3560s and 3750s, you can't really do that. And then the source of traffic could also be a remote VLAN. I'll talk about that in a minute. That doesn't make a lot of sense right now because we have to talk about RSPAN in order to get to that. Now, very important points I want to take away from this is that whether you select one port, a range of ports, an entire VLAN as your SPAN source, I want you to think about all the traffic that's being captured by SPAN. Where's it actually going? It's going out a destination interface, which is the next slide. The SPAN destination is where your IPS or IDS or maybe just your laptop running Wireshark, that's where it's sitting. So let's think about this for a second. If my SPAN destination port is connected to, for example, my laptop, and it's a fast Ethernet interface, 100 megabits per second, but my SPAN source is like 15 or 20 Ingress interfaces, do you see a potential problem with that? We could absolutely have oversubscription or congestion happening where so much stuff is coming in and being copied that the egress port can't handle it all. The egress port in that case would just start dropping stuff. And I would look at my Wireshark or my IDS and my IPS and I'd say, hey, I'm not seeing stuff. I know some stuff is coming in, but I'm not seeing it here in my Wireshark sniffer capture. Why is that? Well, that's because that SPAN destination port is becoming overloaded and it's dropping things. This is one reason why, if you can plan in advance, you might want to choose to use something called a network tap instead, because network taps actually support full line rate. You can get network tap devices that support like 10 gig, 40 gig interfaces. And so oversubscription might not be an issue where it would be with SPAN and RSPAN. Here's another thing to be aware of. So keep in mind that when a frame comes in, ultimately it has to go to the forwarding engine, right? The forwarding engine is the hardware ASIC, the hardware component that says, what do I do with this frame? Where do I forward it? Do I need to modify it or rewrite it? Okay, so the forwarding engine could get overloaded. You could have so much stuff coming in that the forwarding engine starts having to make some decisions about, okay, I'm starting to get congested here. When I get congested, what do I do? Well, Cisco documentation says that in that event, if a port is getting congested or the forwarding engine is getting congested, if any element in the switch is getting congested, SPAN traffic has low priority. So in other words, if the switch is going to drop something because it's getting too overloaded, it's going to drop the SPAN traffic, those copied frames, before it actually drops the real traffic, which once again could translate to you're not seeing on your SPAN output in your Wireshark or your IDS or IPS, you're not seeing everything because there was either congestion on the outbound port or some sort of congestion, and the switch had to make a decision about what it was going to drop, and it chose to drop the SPAN traffic. So be aware of that as well. All right, so those are your SPAN sources. The other thing here I want to mention about selecting a VLAN. So once again, be very careful about selecting as VLAN as your source, because that's a very easy way to overload the SPAN destination port that's leading to your laptop or leading to your network monitoring device. Let's say that's not a problem, okay? Well, the other thing to consider is when you select a physical interface, like we see here, a fast Ethernet, gig, whatever, you also, as an option, get to specify the direction. So it's your choice. You could specify receive, which is everything coming in the cable and coming into the switch. You could specify transmit as your destination. And by the way, a lot of Cisco documentations, when you select transmit, they call that egress span. So if you ever hear that term egress span, that means your span source, whatever it is, your direction you selected was in the transmit direction, stuff leaving the switch. Or you could select both, which is receive and transmit. Now, if you don't select a direction at all, it defaults to both. So for example, if I have one physical interface I'm selecting as my span source, and something sending a ping with both, I'll see both the ingress ping and I'll see the response being sent out of that interface. I'll see both directions. Also, if you do transmit, you're going to see everything transmitted out of that port, including BPDUs for spanning tree, CDP, if that port is sending out the VLAN trunking protocol or the dynamic trunking protocol, all those sort of control frames, you will also capture if your direction is receive or transmit. Or you could capture them on the receive, right? Just depends on what is connected to that interface. Something else I've also read, which is kind of an interesting idea, is that if you know anything about switch architecture, the internal sort of guts of switches, you know that when a frame comes in a port, okay, it's stored in memory temporarily for like a microsecond, then eventually that frame has to make its way to the forwarding engine to be looked up. Okay, well, what is the path that that frame takes from the actual port it came in on to get to that forwarding engine? That depends on the switch. Some switches have what's called a bus architecture. I'll see here if I can draw this. So in a bus architecture, you have something like this, where let's just say this right here is your forwarding engine. So that's the ASIC that's in charge of looking stuff up. And then all your physical interfaces and the ASICs connected to them and the memory connected to them are all connected to like a bus like this. So in a bus architecture switch, so for example, the older Catalyst 6500s used to be like this, like the 6503 and the 6509, if you guys still have any of those in your network. The architecture was like that in the way that when a frame came in, so for example, let's say a frame came in right here, once it went on the bus, every port connected to that bus saw a copy of that frame, including the forwarding engine. And then the forwarding engine would make a lookup decision, and then it actually had a completely separate bus, completely separate physical path where it would send down the result. And that result would say, and that separate physical path would also be connected to all the ports. So imagine this, the frame comes in, all the ports get a copy of it, and now they're waiting to hear from the forwarding engine what should be done. Here comes in the result down the results bus that says, hey, port 0/1, that frame is for you. So if I'm 0/1, now I send it out and I might rewrite it. If I'm some other port, I've basically been holding onto that frame for no reason. Now I say, oh, well, I'm not fast Ethernet 0/1, so discard, throw away the frame. What does that have to do with this? Well, on architectures like that, if you have SPAN configured in the transmit direction, by the way, I'm sorry, for some reason I can't see my mouse, so I have to sort of guess where it is right here. So if this is the port that I'm monitoring, and I'm monitoring it in the transmit direction, well, what that means is that if a frame comes in right here on this port, and let's say that frame was something that was going to be flooded, like a broadcast. Let's say it's a broadcast that needs to be flooded. So all the ports are going to see it by nature on a bus architecture. And we know that the forwarding engine is going to send a result down saying flood. Now let's say that that egress port that I'm actually monitoring is in the blocking state from spanning tree. Now I don't know why you would select a blocked port to monitor, but you could, right? SPAN won't tell you, hey, this port is blocked, don't monitor this. You could do that. So let's say the port I'm monitoring is my SPAN source is in the spanning tree blocking state, and I'm monitoring transmit direction. Well, normally all I would see on a block port that's leaving or going out would be CDP, VTP, you know, all of your sort of control plane traffic, but I wouldn't see any data going out of a blocking port. But in this particular situation, in this architecture, the frame actually made it to that port because it was a bus. All the ports got a copy of that frame on the bus. It was waiting there. And then even though the result from the forwarding engine will come back and say flood, there will be some other element in the background that tells that particular port you're monitoring, okay, but not you. Don't you flood it because you're in the blocking state. So even though you've got this frame that's a broadcast, and even though the result came down and said flood, and you're in the correct VLAN for that, don't flood it out because you're blocking. Well, at that point, the frame made it to the port. It would have gone out if it was a forwarding port. It got the instruction, flood this frame. So SPAN would actually say, oh, this is technically a transmit frame. And even though it actually doesn't go out on the wire, you would actually see it in Wireshark or whatever you're connected to your SPAN destination. Now that would only be in this type of an architecture. There's other types of architectures that don't work like that. That when a frame comes into a port, it doesn't get flooded to all the other ports. It goes directly to the forwarding engine. And then the forwarding engine, once it decides what to do with it, sends it directly to the egress port. But I just want you to know that some documentation states that on some switches, if your SPAN source is monitoring the transmit direction, even if that transmit port is in the blocking state, you still could capture stuff via SPAN that would have gone out, but was ultimately dropped via spanning tree. So that's an interesting little factoid right there. All right, so let's move on and talk a little bit more about the SPAN destination. Oh, also critical thing right here. A SPAN source may belong to more than a single SPAN session. What's that talking about? Let's say that you are Bob, and Bob is a network admin, and you decide that you need to log into the switch and create a SPAN session, and what you're going to be monitoring is port fast Ethernet 0/1. Okay, you want to see everything coming in fast Ethernet 0/1 because you're looking for something specific. Maybe you're looking for unauthorized telnet sessions coming in that port. Okay, so you create your SPAN session. We'll see here in just a second. Let's actually just go to that. Let's take a look at it. So here, I'm going to go into my switch. Okay, and to create your SPAN session, you just say monitor. So even though we're talking about SPAN, the actual keyword is monitor. Monitor session. Now on this particular platform, this is a really low-end platform. This only supports 2 sessions, and that's it. Other platforms can support dozens of SPAN sessions. So I'm going to create my first SPAN session, monitor session 1. Okay, what do I want to look at? Source. On this particular platform, I could select a particular interface. I could select a VLAN. So I'm going to say an interface. Interface fast Ethernet 0/1. And then I get to specify my direction. Now, if I just hit enter right here, it'll be both ingress and egress. I just want to do ingress. So I'll say receive. Okay. Now, I'm not going to complete the monitor session yet. I'm not going to define the destination yet because what I want to show you is this. Let's say Sally comes along. Sally's another network administrator. She decides that she wants to log into this exact same switch, and she wants to create a different session. So, you know, before she logs into the switch, she's very conscientious. She says, okay, show, you know, is there any existing monitor session in here? Show monitor. Oh, okay, somebody already created session number 1. All right, I can't use that number. So Sally logs in and says monitor session. Okay, what numbers are available? Well, there's only one other number, 2. Source. She can actually select the exact same interface. See that? No error messages. she's looking for something different. So we're both looking at the same physical interface. So when stuff comes in that interface, it's going to be copied in session number 1. Session number 1 is going to have some destination, which I haven't configured yet, which is going to lead to my laptop with Wireshark. And I'm looking for something like unauthorized telnet sessions. Sally created a different session, session number 2. She's monitoring the exact same port, but her destination is something else. Her destination is the interface that she's connected to. She's running Wireshark, and maybe she's looking for unauthorized UDP traffic. So my point here is, like the slide says, a SPAN source may belong to more than a single SPAN session. All right, so the destination, we've talked a little bit about this already. So a SPAN destination is one or more ports. So what's that all about? So let's think about this for a second. So in all of my verbal descriptions, I've been saying a SPAN destination is a port that's connected to your laptop running Wireshark, or a port connected to your network monitoring device like your IDS or your IPS. But here we see a SPAN destination could actually be more than one physical port. Why would you do that? Well, maybe you say, okay, I'm going to be monitoring this one interface, Fast Ethernet 01. That's what all traffic coming in there or going out, I want to copy that into my SPAN session. And then I want the copy traffic to maybe go out to SPAN destination ports. Maybe one of those destination ports has an IDS or an IPS that's looking for malicious traffic, looking for malicious signatures of stuff. And I also want to send the exact same copy traffic out a different port where I've got my Wireshark laptop hooked up. So I can just look for various things. You might have multiple reasons why you want to see this captured traffic on different interfaces, because you have different devices connected which have different objectives, different reasons why they want to monitor the traffic. SPAN destination could also be a remote VLAN. We'll talk about that when we get into RSPAN. Here's also a very important point. A port identified as a SPAN destination is monitoring. What does that mean? That means, so for example, let's take a look at this. So if you remember that picture I drew for you about what my topology looks like, on port Fast Ethernet 0/3 is where my laptop is connected. Show interface Fast Ethernet 0/3. So right now, it's up and connected. Now watch what happens to this port when I configure this as my SPAN destination. Monitor session 1 destination interface Fast Ethernet 0/3. First of all, we should see a syslog message pop up here in just a moment. But even if we don't, immediately, if I do show interface Fast Ethernet 0/3, look at this. Physically, it's still up, but the line protocol is down, monitoring. What does that mean? Well, that means that this is no longer a normal switch port. If this had previously been an access port in a VLAN, it's not part of that VLAN anymore. If that had previously been operational as a VLAN trunk, it's no longer doing that. So what this means is that this port is now only being used to transmit to me the SPAN traffic. That's the only thing it's good for. So there's no BPDUs popping out of this port. So this port may have been participating in spanning tree up until a couple seconds ago. Not anymore. Show spanning tree interface Fast Ethernet 0/3. See that? Spanning tree is no longer available on that port. CDP is no longer coming out of that port. All the things that normally were leaving that port are no longer happening. The only thing that's leaving that port is SPAN traffic. Now, what if while I'm running Wireshark on my laptop and watching this stuff, I actually want to use my laptop for other things? Like I want to browse the internet, I want to check my emails. Well, that's going to be problematic because nothing is being received on this port as well. If any Ethernet frame comes ingress or inbound on that port, by default, because it's a SPAN destination, it'll be dropped. So it's like this port isn't even listening on the receive pin anymore. It's just being used to send copies of the SPAN traffic. And that's what this says right here. SPAN destination ports cannot receive any ingress frames. This can be modified via configuration. Now, the Ingress keyword that I'll show you in just a moment when I get to RSPAN threw me for a loop at first when I first read about it. Because if you read the configuration guides, you'll see that when you configure a port as a SPAN destination, monitor session 1, destination interface fast Ethernet 03, you can see here, oh, enable Ingress traffic forwarding. That kind of makes it sound like, oh, okay, well then I could use this interface for two reasons. I could use it to get all my SPAN traffic to my Wireshark. I could also use it with the Ingress keyword to just do normal networking. So now I can browse the internet, I can do my email. After all, that's the problem, right? Right now it's up, down, it's not allowing Ingress frames. I'll talk about in just a second. That's not exactly what the Ingress keyword was meant for. Also important bullet point right here, a SPAN destination may only belong to a single SPAN session. What's that talking about? So remember that analogy I said where I said, okay, I'm Bob, I'm the network administrator, I've got one SPAN session going on looking for something. And then I got Sally, who's also another network administrator. She's on the exact same switch as me, and she has a second SPAN session going on because she's looking for something else. Now in that example, myself and Sally, we were connected to two physically different interfaces. What if that was not the case? Now I know that probably hardly anybody uses hubs anymore, but this is just what comes to mind. Imagine if Sally and I were connected to the same hub. I'm going to try to draw this, although I lose my cursor when I do this. All right, so let's say this is me and this is Sally. And both of us, instead of being connected to the switch, we thought we'd be kind of funny here. We bought a hub off of eBay for a nickel, and we connected that hub to the switch. All right, so here's the switch right now. So now what we want to do is, maybe this is what I'm monitoring right here is my SPAN source. Maybe she's monitoring the same port. Maybe she's monitoring a different port. At this point, we don't really care what the SPAN source is because the problem is we both want this to be the SPAN destination. I want that to be the destination of my SPAN session. She also needs that exact same physical interface to be the destination of her session. Can't do that. So while we could have one interface being the SPAN source for multiple sessions, you can't do that in reverse. You can't have one physical interface as a destination for multiple sessions. That is not allowed. All right, so let's just do a quick example of this with local SPAN. I'll just finish it out here. I've shown you a lot of the configuration commands already. So if you refer back to that picture that I showed you, what I'm going to do is, let's just actually go back to that so we can see it. There we go. Okay, so I'm going to configure a local SPAN session on switch number 1. I'm going to have fast Ethernet 01 as my source, and I'll just leave it defaulting to both for direction. And so I can see anything that R1 transmits or receives, and I'm going to have the SPAN destination as fast Ethernet 03, which is connected to my laptop. I already have Wireshark going up right here. Right now I'm collecting BPDUs because the port I'm connected to is a normal access port. Actually, I think I changed that a moment ago. So let's go ahead. First of all, how do you kill an existing session? I want to start from scratch here. Step number 1 is, do I have any existing sessions? Show monitor. Okay, so I have session number 1. So a real easy way to kill it is just no monitor session 1. And that gets rid of all of it. You don't have to copy and paste in the entire stuff. Okay, there's monitor session 2 as well. No monitor session 2. Okay, so there shouldn't be anything in here. So now I'm going to configure a local SPAN session. So we'll say monitor session 1 source. My source will be a physical interface, fast Ethernet 01, and I'm not going to specify a direction. So it will default to both. do show monitor right now, now shows me that I have a local session. My source in both directions is fast Ethernet 01. Now I have to specify my destination. Monitor session 1, destination, interface fast Ethernet 03. Okay, now if I do show monitor, we can confirm everything. Source is fast Ethernet 01. My destination port of a local session is on the exact same chassis, fast Ethernet 03. Encapsulation native, what does that mean? What that means is that regardless of how the Ethernet frame looks when it comes in, so when it comes in fast Ethernet 01, whether it's a normal native Ethernet frame or whether it's got a tag like 802.1q, or even if it comes in with an ISL header, it doesn't matter. So when it goes out, the SPAN destination port, it will go out as just a native Ethernet frame. So if it came in with a tag, that tag will be removed. If it came in with an ISL header, that'll be stripped off. So here's Wireshark right now. All right. So now look at this for a moment. If you look at this, I'd say, well, wait a second, Keith. Oops, let's go back to that. We're seeing BPDUs here. And you just told me that a SPAN destination port is in the monitoring state. Spanning tree doesn't apply, nothing applies. So this sort of contradicts that. It looks like I'm seeing BPDUs popping out of that SPAN destination port. It looks like that, but that's not what we're actually seeing right here. Those BPDUs are actually popping out of fast Ethernet 0/1, my SPAN source. But because my SPAN source is in the both direction, anything that's leaving that port, including BPDUs, is being sent to me on the SPAN destination. And if I don't know if we could, let's see here, if we capture one of those BPDUs, we might be able to see that, because we know that in a BPDU, it's got a port identifier. See that right there? So that's the sending port ID, 8001. I don't know if we can translate that back to show spanning tree interface fast Ethernet 01. Well, that's how this was interpreted. But trust me, these BPDUs are not BPDUs that are actually natively coming out of fast Ethernet 03 where my laptop is. These are coming out of fast Ethernet 0/1. And another way I can prove that to you is I will just turn on BPDU filter and turn off BPDUs on that interface. Interface fast Ethernet 0/1, spanning tree, BPDU filter enabled. And see that? BPDUs have stopped. So those were the BPDUs that were leaving my SPAN source port. Okay. And right here we can see, so right now the way I have it is that I am actually consoled in, if we go back to this, I'm physically consoled into router 1, and then I'm telnetted from router 1 into the switch. So because it's a telnet session, any telnet commands I enter are going to be coming in, fast Ethernet 01, those will be captured and sent to Wireshark. So for example, see right now I'm not doing much of anything. I'm just going to issue the enter command. Enter, and there it is, right? There's my telnet. So that's an example of a local SPAN session. Now what if the frames coming in did have, let's just stick with 802.1q, did have 802.1q tags, and I want to see those tags. How would I see that in Wireshark? Well, first of all, let me show you that you won't see them. So if I go back to my router, you'll notice that on my router's interface, fast Ethernet 00, I've intentionally configured it with an IP address on the primary interface. So anything that uses that as a source will just be a regular native Ethernet frame. I've also got this sub interface right here, which is using .1q, VLAN 2, and this. So here's what I'm going to do. I'm going to ping something that starts with 12.12.12 that doesn't actually exist. I'm going to ping, for example, 12.12.12.99. Now that doesn't exist, but what that will do is that will cause this guy to create an ARP request. His ARP request will go out that sub interface, and because that sub interface is doing .1Q, it will tag it with a VLAN tag of 2. The question is, when my SPAN captures that, will I see that tag? So there we go. See that? There's the ARP. And if I enhance this, no mention here of a tag. So that shows you that that tag is being stripped off. Well, how do I actually see it? What if I do want that to show up in Wireshark? Okay, well now I have to modify my SPAN destination command to actually see that tag. Oops, don't want to do it in the router. So I want to go into switch 1. Now, usually what I do is I would completely remove my SPAN destination command, and then I would re-put it back in with an additional keyword. I'm going to see if I can just do it on the fly, see what happens here. By the way, your SPAN stuff is all the way at the bottom of your config. So if you look at your show run, all the way down here are your SPAN commands. So let's just see if I can modify this without actually stripping it out and redoing it. Okay, so notice here, I have the encapsulation command. And in this particular platform, I have 2 choices, .1Q and ISL. So what this is used for is if I suspect that on any of my SPAN sources, now in this case, I've just got one SPAN source, but let's say I had multiple SPAN sources, multiple interfaces. Some of them were access ports, some of them were trunks. And my objective was, okay, if anything comes in any of those ports, if it does have a tag, I want to see that .1Q tag. Then I would say encapsulation .1Q. Now on this particular platform, I could have a problem because what if some of my SPAN sources were doing .1Q, other SPAN sources were doing ISL, and I said, hey, if anything comes in, if it's got a .1Q tag, I want to see that. If it has an ISL header, I want to see that. In this particular platform, on this 3560, I don't have that choice. I can select one or the other. I can't select both. What you might see on your switches is you might see after encapsulation, you might see a third option which says replicate. That's good because replicate is just like it sounds. It says, if I say encapsulation replicate, that means, hey, whatever the encapsulation was when it came in, .1Q, ISL, or nothing, keep it exactly as you saw it and send it to my SPAN destination port. Unfortunately, in this particular platform, I can't do that. Okay, so I didn't get any error message when I modified the command. Let's make sure it actually took it. Show monitor. Okay. So destination port is fast Ethernet 03 and encapsulation now says .1Q. So now when I do that same test, when I ping something that doesn't exist, that has a .1Q header on it, and there we see it right there, see, 802.1Q. Now the tag is being included as part of my SPAN destination. I can see right there, ID 2, that's my VLAN, VLAN 2. All right, now one other thing I want to talk about is this Ingress, but to really get the full power of that and what it means and what it doesn't mean, I first want to talk about RSPAN. So let's talk about that. Okay, so as I mentioned earlier, the idea of RSPAN is that we have one switch that has my SPAN source on it, like a physical interface or a range of interfaces, but the SPAN destination port is actually located on a completely different chassis, like in this case, switch number 2. So how do I get my captured traffic from switch 1 over to switch 2? And when it gets on switch 2, how does he know, how does he recognize that, hey, this traffic coming in isn't normal traffic, it's actually traffic that should go out the SPAN destination? Well, the way we do that is we configure a special VLAN called a RSPAN VLAN. So as you can see in this slide right here, on both switch 1 and switch 2, we would select a VLAN that's currently not in use. So you don't want to use a VLAN that's already got access ports or trunks on, so a completely unused VLAN. Configure as normal, but then when you're config-VLAN mode, you actually say remote-span. Now, if I actually had like 5 switches end to end, all the switches would have to have this. All the switches would have to have VLAN 300, and they would all have to know that it's a remote span VLAN. I was actually kind of curious about that earlier this morning. I thought, okay, well, if I have, let's see if I can draw this too, just so you can see. Where is my, all right, well, I can't get to that. But imagine if you have 3 switches here end to end. My thought was, okay, if switch number 1 recognizes that a VLAN is an RSPAN VLAN, let's talk briefly about what that means. What an RSPAN VLAN means is when traffic comes in my SPAN source ports, instead of sending out a physical interface, which would be a local SPAN session, that traffic is going to be copied into this special VLAN, this RSPAN VLAN. And so any trunks, any normal VLAN trunks that switch 1 has in this case, we know that a VLAN trunk carries all VLANs by default, which will also include my RSPAN VLAN. So as traffic comes in the SPAN source, it'll be copied into the RSPAN VLAN and then sent out the trunk with that tag. In this case, it would be tagged with .1Q or whatever the trunk is using as VLAN 300. So my idea was, okay, well, if I had a switch in the middle, switch 1, 2, 3, what if switch 2 just had VLAN 300 configured, but it didn't know that that was an RSPAN VLAN? Logically thinking, you would think, okay, well, if the frame comes in with 300 in the tag, switch number 2 will look at the destination MAC address and he won't find it. So he'll say, okay, I should flood this then. What other ports do I have that's carrying VLAN 300? Oh, here's another trunk over here that's going to switch number 3. You would think it comes in with 300, gets flooded out on 300, and then makes it to the 3rd switch that does recognize the RSPAN VLAN. Logically, you would think that should work. It doesn't. And actually, Cisco documentation will tell you, it'll say, hey, if you've got 3, 4, 5 switches all in a row, they all have to have the VLAN and they all have to know it's an RSPAN VLAN. Architecturally, I don't understand why that is the case. You know, I tried it in the lab. I had VTP turned off. It wasn't a VTP thing. Something about that intermediary switch still knows somehow that this VLAN shouldn't be a normal VLAN. It should be an RS, and it did not carry the traffic all the way through. So I can tell you that Cisco's documentation proved out in the lab is correct. If you've got a line of switches, they all need to know that this VLAN is not normal. It's a remote span VLAN. So that's step number 1. On all your switches, configure an unused VLAN as a remote span VLAN. Then on switch number 1, in this case right here, let's go back right here. You configure your SPAN source as normal, 1 or more physical interfaces, and then your SPAN destination is actually that remote VLAN. And you can see right there the command for that, monitor session 1 destination remote VLAN 300. Now, as I mentioned, if this switch number 1 had 10 VLAN trunks, this copied traffic would be going out, all of them. Now you might think, well, I don't want that. You know, I only want it going out fast Ethernet 0/2. That's the trunk that I want to go out. How do I not get the SPAN traffic to go out the other trunks? Real easy. Just use the switch port trunk allowed command. So if you're familiar with that command on a switch, for example, not right there, switch 1, you can go on to an interface that's trunking, show interface trunk. So for example, on this switch right here, 0/21 is trunking. I could go interface fast Ethernet 0/21, and then you could say switch port trunk allowed VLAN. Now if I said, okay, I don't want this trunk carrying my RSPAN VLAN. Oh, my RSPAN VLAN is 300. Well, then accept 300. So that would say, okay, this trunk is allowed to carry all the VLANs except that one, because I don't want my captured traffic going out that particular trunk. That's how you would have to prevent that from happening. Okay, so let's move over to switch number 2 now. Switch number 2 has the RSPAN VLAN configured. that RSPAN VLAN is what his source is. So when you use the monitor session command here as a source, VLAN 300 is that source, and then your destination in this case is your physical interface that's leading to your Wireshark PC or your IPS IDS box. Okay, now here's where I want to demonstrate something. Let's go back to the physical picture real quick, and then this will be the last thing I'm going to demonstrate, and then we'll take whatever questions you've got. So I'm going to configure on switch number 1. So let's just go ahead and do this. I'm going to use Fast Ethernet 01 as my source, so I don't have to change that. I'm going to configure VLAN 300, remote-span, okay? Do show run, begin monitor. So I'm going to change my destination command. It's no longer going to be a local span. Now my destination is actually going to be remote VLAN 300. Hold on a second. Monitor session 1 destination remote VLAN 300. This is the first. I know what a reflector port is. I'm just sort of pausing because I've done this lab 1,000 times on here and not had to use this. I suspect it's because I'm converting from a local span into a remote span session that's causing me to select this. Oh, it's actually because, know what it is. It's because I'm using a 3550 in this case. All right, so let's talk about the reflector port since we're here. You won't see this on most switches. In my particular case, my switch 1 is an older 3550 switch, which I don't think you can even buy anymore from Cisco. And on that particular platform, in order to do RSPAN, you needed this thing called a reflector port. What is that? Well, a reflector port basically was the port that is your span source. For some reason that's beyond what I know, the architecture of that port did not have the capability, the ASIC on that port did not have the capability of copying the traffic onto an RSPAN VLAN. It couldn't do that. So in the architecture of this particular switch, you'd have to select an unused port. Now what I mean by unused is exactly like it sounds, a port that's not connected to anything. No cable, it's just a port that's basically going to be a throwaway port. And you're basically using the ASIC of that unused port, that's what we call the reflector port, to do the copy of the traffic, to copy it onto the RSPAN VLAN. I don't want to go about and do that, so let's change this a little bit here. So in my picture, what I'm going to do is I'll actually use switch 2. I'll have Fast Ethernet 04 as my source. That is a 3560. That's not going to require a reflector port. So let's go to switch 2. First of all, let's get rid of my monitor session on switch 1. All right, let's go to switch 2. Okay, show monitor. There should not be anything on here. Okay, so monitor. First of all, let's create our RSPAN VLAN. If I could spell, that would help. Okay, so now we go monitor session 1 source interface Fast Ethernet 04. That's the one that's connected to router 4. Now monitor session 1 destination remote VLAN 300. And notice because that's a different platform, no mention of a reflector port. So chances are you're probably not going to run across that reflector port thing in your environment. All right, so that's all I have to do. Show monitor. I can see there that I've got a source port of Fast Ethernet 04, which is going to be in both directions. RSPAN VLAN of 300. And if I do show interface trunk, we can see that I've got a couple of trunks here, and VLAN 300 is in the allowed list. So it should be on there. Show VLAN remote span confirms that VLAN 300 is indeed being recognized as a RSPAN VLAN. So now I go over to switch 1. It's going to be receiving this traffic. Okay, show monitor. I think I deleted everything on here. Okay, I still have my VLAN though. Show VLAN remote dash span. So VLAN 300 is already pre-configured here. So now in this guy, monitor session 1 source. Now my source is going to be that remote VLAN. Don't need any reflector port in this particular case because it's already coming in tagged with that VLAN number. And monitor session 1 destination is going to be my interface is connected to my laptop. Show monitor. Okay, so we see the source is anything that comes in any trunk that's tagged with VLAN 300. It recognizes this as an RSPAN session. Where's it going to send all that captured traffic? To my laptop, which is connected on fast Ethernet 0/3. Encapsulation is native. Let me pause here for a second. Now, once again, you might say, hey, okay, on my source switch, I have a source of many different ports. I got some ports which traffic is coming in tagged with .1Q, some ports tagged with ISL, some ports which are access ports. And what I want to do is I want to see all those original tags. So I'm over here on switch number 2. That's the destination. I want to see what the original tags were of the source switch. You can't see that. You see, even if I put encapsulation here of .1Q or whatever, think about how's that traffic actually look as it's going across the trunk. The original tag or the original ISL header is gone. It's lost. What's in place of it? VLAN 300. Our RSPAN VLAN is now being replaced as that tag, and that's what's going across. So even if I did encapsulation .1Q, all I would see, and actually let's go ahead and do that. Monitor session 1 destination, interface fast Ethernet 0/3, encapsulation .1Q. So all I'm going to see now is that VLAN 300 as it comes in. So let's try this out. So what I'm going to do is I'm going to, from router 1, I'm going to ping router 4, and I should be able to, as that traffic leaves 04, should be picked up, and it should be sent back across the RSPAN VLAN, and so I should be able to see it. Let's make sure Wireshark is all set up, ready to go. Let's just start a fresh capture here. Ping 2224. There it is. Let's just pick one of those. And see that right there? We do see the .1Q tag, but regardless of what it was, it's always going to be the exact same number, the RSPAN VLAN of 300. So it's kind of pointless to set the encapsulation on the destination port since I'm always going to see that. All right, so that leads me to my last topic I want to talk about. Now, right now, if we take a look at that destination port, show monitor, notice it says Ingress is disabled, which means that if I actually want to use my laptop to browse the internet, do email, I couldn't do that because Ingress is not allowed. Well, what if I do turn on Ingress? Now, in order to do this, I'm going to change it up a little bit because if I give my laptop an IP address on that Ethernet cable, my laptop's going to prefer that over the Wi-Fi, and I'm going to lose my session to you guys, and I don't want to do that. So what I'm going to do is I'm going to have as my destination router 3. I'll change my destination port to 024. So let's do that. So let's get rid of this. Okay. And now let's put it back in. We don't need the encapsulation command. Instead, we want to make it 0/24. Okay, so Wireshark at this point is kind of pointless because I am no longer the destination, so we can close that off. Okay, so how can I, when I have a router here in this case, how can I actually prove that that 0/24 is actually sending copies of the traffic out to him? Well, here's a real crude way I can do this. So I can go into that interface, change the load interval down to the minimum, clear the counters. Okay, so let's take a look. Show interface fast Ethernet 0/24. So right now this is a monitoring port. So really the only thing that's being transmitted out of this, there's no BPDUs going out, there's no CDP going out. So notice 0 packets output. If I do it again, 2 packets output. What is that? Well, that is the CDP or possibly the BPDUs that are going out fast Ethernet 04. So whatever right now is being transmitted out fast Ethernet 04 is being copied and sent out my SPAN destination, which is 0/24. And so here's another way I can prove that. I'll go to router 1. I'll ping 2224, that's router 4, and I'll repeat that like 5,000 times. While that's going, I'll go back to the switch. All right, well, let's just go ahead and repeat that 5,000 more times. That's good enough. So switch 1, show interface fast Ethernet 0/24. And notice 11,000 packets output. So that is my SPAN destination port. That proves the packets actually went out to router 3. Now, if I actually get onto router 3, if we keep a look at our picture right here, you might think, okay, well, router 3 is in the 222 network. I do not have Ingress turned on. Ingress is disabled. Notice the port is down monitoring. So I'm going to go to router 3 now. R3. Oh, okay, I actually have to connect my console. I can't telnet to him. All right, so here's router 3. Can I ping somebody in his own VLAN? Can I ping router 2? Nope, right? Because ingress is not allowed. So you think, oh, okay, well, I'll just go back to my switch and turn on ingress. And that should allow me to have bidirectional communication. So we'll just go to this right here. We'll put in ingress. Let's see, he's already in VLAN 2, so we'll just say ingress VLAN 2. Show monitor VLAN 2. Okay. So watch what happens when I ping from router 3 to router 2. When I ping 2222, a person in his own VLAN. Ping 2222. Maybe it's ARPing. Nope, that's not the problem. He's not able to ping. You say, but what happened? Did ingress, isn't ingress supposed to allow ingress frames? Okay, what happens if from router 3 I ping router 4? I get a response. What is going on? Here's the logic behind what's happening here. The intent behind the ingress keyword is not that whatever's connected to that SPAN destination port now has full bidirectional connectivity to send whatever it wants to whoever it wants and get a reply back. That's not the intent. The intent was this. If that was an intrusion prevention device, an IPS box, and it's a SPAN destination, and all of a sudden that IPS box, let's say it detects some sort of TCP-based attack. Maybe that IPS box would want to react to that and send a TCP reset back to the source. So the idea is, hey, the IPS box doesn't care if it gets a response to the TCP reset. We just want the IPS box to be able to send a unidirectional packet into the switch, TCP reset in this case, which will eventually make its way to the attacker and reset that TCP connection. We don't care to get anything back from the attacker. That is the intention of Ingress. So when you put that Ingress keyword on there, yes, it does allow whatever's connected to that SPAN destination to send frames into the switch, and away they go wherever they're meant to go. But remember, the transmit direction is still only for SPAN traffic. So when I pinged from router 3 to router 2, that ping did make it to router 2. If I was doing a debug on router 2, we would have seen the ping come in because ingress was allowed on 024. We would have seen router 2 respond to that ping. But when that response comes in, switch 1 would say, oh, well, I can't send that response out 024. 024 is a SPAN destination port. The only thing I'm allowing out of that interface is SPAN traffic. So how's that work when R3 pinged R4? Well, when R3 pinged R4, R4 got the traffic, he got the ping, he sent an echo response, a ping reply, and guess what? When that ping reply came in 0/4, that is a SPAN source port. That got copied onto our RSPAN VLAN of 300, and that made its way back to router 3. That's why router 3 actually saw the ping response from router 4, but he didn't see it from router 2. So the takeaway here is that when you enable the ingress keyword, remember, that does not change the behavior of what that port is allowed to transmit to the destination. And that, my friends, is all I have to say on SPAN and RSPAN. So that concludes everything I want to talk about right here. And that concludes that particular section.
There we go. Well, thank you so much, Keith. We are going to take a couple of questions. I know we're running a little bit over time. If you do have to leave the webinar a little, or not really a little early, but if you need to leave the webinar for any reason at all, this will be recorded and sent to the email that you registered with. So be sure to check your email inbox probably a little bit later this afternoon. We'll also have it on our social channels, INE on Facebook and Twitter, as well as we will eventually be getting it onto INE.com. So if you want to take a couple of questions, Keith, I will get that set up for you real quick.
All right. Thank you so much, Brittany. Okay, let's take a look and see if there's any questions here. And I do apologize, guys, for running over. This is our first webinar. This is my first webinar of doing this. I didn't really know how long this was going to go. So I appreciate those of you who stuck around with me here. Okay, so there's a good question here. And I will answer it. I'll just say answered live. Right there. So the question, hopefully you guys can all see this, is can we use access lists or prefix lists to filter the interested traffic on the monitored interface? Very good question, because yeah, you're absolutely right. The SPAN source, whether it be RSPAN or local SPAN, is capturing everything. And so maybe that's not what you want. Maybe you only want to capture certain stuff. The short answer is, it depends. It depends on your platform. From what I've looked into and what I've read, if you're on a Nexus switch, the answer is yes. On a Nexus switch, when you create your monitor session, an option is something called the filter command, and you can actually say filter access group, and you can have a filter referencing an access list, and so then you're only capturing stuff that the access list is permitting. That's on Nexus switches. Unfortunately, everything I looked into and could find on Cisco iOS switches, you don't have that option. On Cisco iOS switches, there's no way to only filter based on a prefix list or an access list. It's pretty much all or nothing. Now, you do have a little bit, you do have one thing you can do. On an iOS-based switch, and I'll go ahead and show this to you here. Let me go back to this. So if I say monitor session 1, notice there's a filter command. I could say filter VLAN 2. What that does is that says only traffic that was captured on VLAN 2 is what I want to see. So for example, if my source was a trunk that had, let's say, 100 VLANs on the trunk, I could use this to say, hey, look, I don't want to span all 100 VLANs that are being received on this trunk. Only traffic that's coming in on VLAN 2 on the trunk, that's what I want to send by span destination. So on iOS-based platforms, that's about as specific as you can get as far as filtering is concerned. All right, let's see if there's any other. So there's a question here. I'll just say answered live. The question is, I tried to use local span in conjunction with multiple switches instead of RSPAN, but it didn't work. It sounds ridiculous, but could you explain the logic behind that? So I'm assuming what you're saying is that you had one switch. Let's go back to my picture here for a moment. Like this. And your intention was you wanted switch 1 to have an interface with a span source. You wanted to send that traffic to switch 2, but instead of using RSPAN, you just selected like fast Ethernet 0/22 as your span destination port. You didn't create an RSPAN VLAN or anything like that, and you expected switch 1 to pick that up. So let's think about this here for a second. If fast Ethernet 0/22 was your span destination, your physical interface was your span destination, all the traffic should be sent out that interface. And then if on switch number 2, if that was your span source, why wouldn't that work? That's a good question. I'll have to think about that a little bit, about the mechanics of that, because you would think that the traffic should be leaving. So if the traffic was going out this way, if this is my destination right here, so yeah, it's going to be in the monitoring state, but the traffic should still go out that interface. Forget about it being .1Q for a second. So if this was the span source, a local span session on here, traffic comes in, it's a normal, well, I would think if it's normal native Ethernet frames, then switch number 2 should get it. He should be able to pick that up, and he should be able to send it out here as a span destination. It could be problematic if these frames came in and they were tagged. For example, if this was your span source over here, and this was a trunk, and you were actually preserving the tags, that could be a problem, because when they came in 0/22 and it had an existing 802.1Q tag on it, switch number 2 could say, wait a second, this is an access port. This is not a trunk. If I see something that comes in tagged, that's illegal, that's not allowed, and that could cause him to drop it. So I don't know if your topology had that or not, but that could potentially explain the situation that you were seeing. All right, what other questions do we have here? I'm going to go down because I may have answered a bunch of your questions already. So I'm going to go down to the, okay. What else do we have here? Is it so there's a question here, let's say answered live. Is it possible to send remote SPAN to remote site server through an MPLS link? In my research yesterday that I looked at, I did see some mention of a way of doing that where your SPAN destination could be using something called XConnect, and then it had MPLS as part of that keyword. I didn't go any further than that, so it looks like that is something that is theoretically possible. What I would recommend doing to get an answer to that is just Google the keywords of Cisco, RSPAN, XConnect, and that will probably lead you to that same document I was looking at that mentioned XConnect in conjunction with MPLS. So I would use that as your keywords, Cisco, RSPAN, and XConnect, and you'll probably see that. All right, so here's another question on the reflector port. The reflector port, is it only for certain switches? I mean, if I had to do a 4500, do I need to use the switch capability, or is it good enough? So yeah, the reflector port is only on certain architecture. On a 4500 or a 6500 or a 3560, you're not going to see that. As far as I know, it's only the 3550 platform where I've ever seen that need for a reflector port. I haven't been able to test it on other architectures. So yeah, it should be a very limited where it's only a hardware-based thing. So 3550, if you have those, definitely you'll see that. I don't know about other platforms, but it should be rare that you have to deal with the reflector port. And like I said, if you do see that keyword, that unfortunately means you're going to have to specify, and you're going to have to basically burn up an unused port, no cable, and that port will be your reflector port. And a reflector port basically means, okay, that port that's not used is now going to be in charge of copying my SPAN source traffic onto my RSPAN VLAN. Because unfortunately, the SPAN source interface itself doesn't have the capability of doing that. But like I mentioned, as far as I know, 3550s are the only ports that have that. All right, let's see here. And yes, I'll send this to everybody here. Answered live. So as far as the Nexus switches, now I am not a Nexus expert. I have a lot of experience with iOS. I have like this much experience with Nexus. But over the last couple of days, I did spend a little bit of time researching SPAN and RSPAN on Nexus switches. Some of the things I found was that number one, with Nexus switches, you do have that additional capability of filtering based on an access list, which is kind of nice that you don't have with iOS-based switches. It also looks like many of the Nexus switches support SPAN and ERSPAN, but they don't support RSPAN. So they don't support remote SPAN, but they do support SPAN and ERSPAN. So if I was thinking of purchasing a Nexus switch, that's one of the things you might want to research in advance is, does this particular model of Nexus switch support remote SPAN? Because remote SPAN is very popular. And it looks like a lot of Nexus switches don't support remote SPAN. All right, let's just take 2 more questions here. Real easy question here. I can burn this one up in 10 seconds. Do we get charged for this webinar? No, it's absolutely free. So no charge for you. Now, if you want to give me your credit card number, I would be happy to take advantage of that. But no, we are not charging you for this. And some people are asking about the video. I do know that all of you who are actually on this and who registered for it will get a link for the video. So if you haven't gotten that already, you should be getting that sometime very shortly. So you will have this for posterity's sake. And so the last question I'm going to answer here live is, does SPAN and RSPAN work with routers? And so the answer is no. So now some routers, if it's a modular router, you could potentially put an ether switch module into it, and the ether switch module itself might support SPAN or RSPAN, but the actual routers themselves do not support that. So if you want to do something like that on a router, there are other features available, but not SPAN and RSPAN. So with that, we're about 20 minutes overdue. I apologize for that, but hopefully this is a very interesting and informative session for you guys. I really appreciate you spending your time with me today, and thank you for tuning in, and look forward to our next session coming up in April, which will deal with spanning tree. So have a great day, everybody.
Thank you, Keith. Like you said, this is all going to be available in your email inboxes, hopefully by mid-afternoon. You will be able to also get a copy of all of Keith's slides in case you need them. And if for some reason we weren't able to get to your question, you can send us an email. You can send it directly to Keith if you'd like. It's KBOGART, so like Keith Bogart, at INE.com. Thank you guys so much for joining, and we will be with you again soon.